Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit number 5, Lesson number 7, Solving Systems of Inequalities. Before we begin, let me remind you that you can find a worksheet that goes with this video along with a homework assignment by clicking on the video's description or by visiting our website at www.emathinstruction.com. As well, don't forget about the QR codes on the top of every worksheet. Use your smartphone or tablet to scan those codes and bring you right to these videos. Okay, so previously we've learned about systems of equations and systems of inequalities. We've also learned about how to graph linear inequalities in two variables. Today what we're going to be doing is combining all of those to graph the solution sets of systems of inequalities. All right, but first let's jump in exercise 1. Take a look at a system of inequalities, all right, and try to figure out whether particular points are solutions to those systems, all right? So what we want to do is we want to figure out if the point 3, 8 is a solution to that system. Now, it doesn't matter whether it's a system of equality or a system of inequalities or a mixed-up system. The plain fact is a point is a solution to a system if it makes all the equations, or in this case, inequalities, true. So let's take a look in letter A. If I take that first inequality, x plus y is greater than 10, and I put 3 in for x, and I put 8 in for y, right? I'll get 11 is greater than 10, and that's true. If I take the next one, y is greater than or equal to 3x minus 5, and I put 8 in for y, and I put 3 in for x, I'll get 8 is greater than or equal to 9 minus 5. 8 is greater than or equal to 4. That's also true. Because I have those two truths, the answer is yes. So at the end of the day, in letter C, we're going to graph the solution set to this system of inequalities. 3, 8 better be in there. Why don't you pause the video and see if the point 5, 9 is a solution to this system of inequalities. All right, let's go through it. Hopefully this time you found that the answer was no. But let's take a look. I have x plus y is greater than 10, so I'll put 5 plus 9 in there. Greater than 10, 14 is greater than 10. Well, that's true. Let's try this one. Y is greater than or equal to 3x minus 5. So I'll put 9 in there, and I'll put 5 in there. 3 times 5 is 15, minus 5. 9 is greater than or equal to 10, and that's false. Now, it doesn't particularly matter that this one's true. The plain fact is if any of them are false, the answer is no. So just as we pointed out in letter A, when we ultimately graph this thing, that point shouldn't be in the solution set. So let's remember how to graph inequalities. And actually, I'm going to start with this one, y is greater than or equal to 3x minus 5, because it's the easier one. Remember what we're going to do is we're actually going to first graph this equation, y equals 3x minus 5. That should be pretty easy, right? We have a y-intercept of negative 5, and we have a slope of 3 over 1. So 1, 2, 3, 4, 5, all the way down here. We're going to go up 3 and to the right 1, up 3 to the right 1, etc. Now we have to make a decision whether or not we then connect these with a dashed line or a solid line. Do you remember how that works? Hopefully. If there's an equal sign here, which there is, then we graph it with a solid line. Oh, not my best solid line. And we label it with its equation, y equals 3x minus 5. Okay. The reason I wanted to do that one first was because the y was also already isolated. In this one, there's a little bit more of a challenge because the y, is not alone. I don't know why I put the equal sign in there. It's not there. X plus y is greater than 10. Now, that's not a problem. I can subtract x from both sides. Now remember, a property of inequality is that you can add or subtract anything you want from each side, and it's not going to change that inequality symbol. That inequality is only going to flip, right, if we divide by a negative. Now what we want to do is we want to graph y equals 10 minus x. Okay, in this case, that b is 10, and that m is negative 1 over 1, right? Now, how do I know that? Because I can use the commutative property of equality, just the commutative property of addition, to flip-flop that 10 minus x and make it into negative x plus 10. So here we go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down one to the right one. Etc. All right. Now, in this case, though, right, in this case, since there is no equal sign, we need to draw this in dashed. All right. But now we've got some shading. Okay. In the first one, it was y is greater than or equal to 3x plus 5. So we're going to shade above this line. And actually, I'm going to change my color to red for the other one. The other one was also greater than. Y is greater than 10 minus x. So I'm going to shade above this line. Now, what exactly is my solution set? Well, remember, my solution set will be all the points that make both of these inequalities true. Well, that is going to be this little triangular region right up here. Okay, that is my solution set. And if you notice, right, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, there's my 3, 8, right? On the other hand, my 5, 9, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 is not in the solution set, right? It's not in the double overlap. So the solution set to a system of inequalities is where the two parts of the shading overlap, if they overlap at all, right? But that's it. That's the whole story. Okay? So pause the video now. Really think about what we did, because essentially we did the whole lesson here. We really did. It's just a combination of other things that we've done. I'm going to clear this out in a moment, though, so pause the video. All right, here we go. Okay, that's gone. Let's move on to the next exercise. So exercise number 2. On the grid shown below, graph the solution set to the system of inequalities shown below. State a point that lies in the solution set and one that doesn't. All right, well, let's start off with this guy. But maybe not in green. I mean, we could. Now, this one also already has y isolated, so I'm going to change it into an equation, y equals negative 3 halves x plus 2, right, where clearly the y-intercept is 2, and the slope is negative 3 divided by 2, so that's going to be pretty easy to graph. I'll do that, go down 3, to the right 2, reverse it, go to the left 3, up 2. All right, should be dashed, right? Dashed, because there is no equality there, so the points along that line are not included. The boundary points are not part of the solution. That's why we dash it. And then I think I'll do the shading right away. We're supposed to shade under it because it's less than. So any point in there, and I think I'll label the equation of the line. Y equals negative 3 halves x plus 2. All right, let me change colors. Let me go to red now for the next one. Now, what do we do with this guy? Well, the line it's based on is x equals negative 2. All right, but that is a vertical line, right? It's the line that has all x coordinates of negative 2. So, for instance, that point's got an x coordinate of negative 2, and that point, and that point, and that point, right? It's all points that have x coordinates of negative 2. All right, and it should be solid because the equality is included. So I'm going to draw a nice solid red line as well as I can, not all that great. Label it x equals -2, and now it's greater than. Now that's a little weird, right? Because it's not above or below, it's right, left, and of course greater than in this case is going to mean to the right, because all x coordinates to the right of -2 are greater than it. Okay, so that's it. I mean, that's the whole deal. Now, what's interesting is, again, the solution set itself is sort of this overlapping region, which includes this boundary, but doesn't include that one. So the last part of the problem says, give one point that's in the solution set. Well, there's tons of points, tons of them. Here's a really good example. Here's a point that's in the solution set, and that's got the coordinates -1, 1. On the other hand, there's also lots of points that aren't in the solution set. For instance, this point is not in the solution set, and it's at 1, 2, 1, 2, 3, 4. But that's it. That's the whole deal. So, graph the lines that the inequalities are based on, shade according to greater than or less than, and wherever the shading overlaps of the two inequalities, if at all, that is your solution set. Okay, pause the video now and I'm going to clear out the text. Here it goes. All right. Exercise 3. Nice little multiple choice problem. Which of the following points is the solution to the system of inequalities shown below? Show the work that leads to your answer. Well, we have no graph paper here. All right, if we had a piece of graph paper, we could do the full-on problem, graph it all, and then simply plot the 4 points. But here we really have to rely on truth values. And it's kind of annoying. It's kind of a guess and check thing. But remember, if either one of the two are false, then the whole thing is false. Okay? So let's do one. Let's walk through one that is false, and then have you work to find the one that's true. Okay? So let's try number 1. Okay? The 3, -6. Let's try y is less than or equal to -4x plus 2. So I'll put -6 in there, less than or equal to -4 times 3 plus 2. -6 is less than or equal to -12 plus 2. -6 is less than or equal to -10. Well, that's actually false, right? -6 is greater than -10. Remember that if you struggle with comparing two negative numbers, think about them in terms of temperature. Which one is warmer, right? They're both cold, but -6 is warmer than -10. So that's a false statement, which means I don't need to do any more work on number 1. It can't be a solution to the system. So pause the video now, work through your other 3 choices, and see which one makes both of those inequalities true. All right, let's go through it. The correct choice here actually ends up being choice 3, okay? And let's work through it really quick. -2, 10. All right, here we've got y is less than or equal to -4x plus 2. If I put 10 in, right, I get -4 times -2 plus 2. -4 times -2, a negative times a negative is a positive. And I get 10 is less than or equal to 10. Had that just been a less than, the answer would have been false. But because there's that equal there, it's true. Likewise, let's check this one. Y is greater than x divided by 2 plus 7. Oops. Let's put in the 10 for y, greater than -2 divided by 2 plus 7. Negative divided by a positive is a negative. And -1 plus 7 is +6, and that's also true. So since both inequalities are true at that point, it is part of the solution set. The other 2 choices either fail in both of the inequalities or fail in at least one. All right. So pause the video now, write down anything you need to. All right, here we go. Now let's move on to the last problem. Exercise 4, I like this one a lot. Consider the system of inequalities given below. Determine which, if any, of these points is a solution to the system. So I've got these 2 points. I want to know, are they solutions to this system? And I know it's now 3 inequalities. That's okay. We'll live with them. 2 of them are very, very simple. So check. Pause the video now and see if either one of those points is a solution to that system. Remember, all 3 have to be true. All right, let's go through it. Well, let's check them one at a time. This inequality, y is greater than or equal to -2. Well, is 4 greater than or equal to -2? Yeah, that's true. 1 down. Our next one is x is less than 4. Well, is -1 less than 4? You bet it is. That's true. Our last one is y is less than or equal to 2x. That will be 4 is less than or equal to 2 times -1, or 4 is less than or equal to -2. That's a false, and therefore no. Came so close, 2 out of the 3. All right, let's try this one. So y is greater than or equal to -2. Well, that would be 1 is greater than or equal to -2, and that's true, right? Because 1 is bigger than -2. All right, then we have x is less than 4. That's 3 is less than 4. That's certainly true. And y is less than or equal to 2x. That would give me 1 is less than or equal to 2 times 3, or 1 is less than or equal to 6, and that's certainly true. So yes. So when I eventually am asked to graph this thing, well, we know that the first point won't be in the solution and the second will. So let's do it. I'm going to do some of the writing up here as we graph it down here. But y is greater than or equal to 2. We'll do that one in blue. That's going to be based on this horizontal line, right? Horizontal line. It's the line where all y coordinates are -2. So for instance, this point, this point, this point, etc. Right? I don't think I really have to draw them all out, but every single point along that line has a y coordinate of -2, and yet here I am doing them all. All right, solid or dashed, looks like it should be solid because the equality is included. And greater than means that we should shade up here. All right, y is equal to -2. I keep forgetting to label my lines. All right, let's do the next one. X equals 4, that's going to be vertical. Right? And that's 1, 2, 3, 4. Any point along this line, right, has an x coordinate of 4. Solid or dashed? Well, it's just less than, so that seems like it's dashed. Right? That's definitely dashed. Okay, and let's see, it's less than, so this is going to get to be a little bit of a complicated picture, but that means we've got a shade to the left. There we go. And let me go the last one in green. Here we'll go with y is equal to 2x. Now, this one's interesting because this is definitely a slanted line, right? Both the x and the y are there. I put that plus 0 in just for us to be able to think about the y-intercept of being 0 and a slope of being, whoops, that's not a y-intercept of 0. Oh, this is going to be tough to erase. I got to go super duper small. There we go, that worked. There's my y-intercept of 0, and then I'm going to go up 2 and over 1, up 2 and over 1. Sorry about how messy the picture is getting, but we do have 3 boundaries on there. All right, solid line, because, let me go back to red and label that other line. X equals 4. Now go back to green and do some shading. That's going to be less than, so it's going to be under that line. Ooh. So where in the world is my solution set? Let me outline it in black, right? It's wherever the shading crosses each other, right? All of them together. all in here, over to here, and down to here, right? Everything in here is the solution set. Everything in there. Now, letter C asks us to find the area of the portion of the xy plane that represents the solution. Well, let me pull that little puppy out. It's a nice right triangle. We can figure out its base, 1, 2, 3, 4, 5. Figure out its height, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so not the nicest. Well, wait a second, 9 or 10? Oh, no, we're all the way up to here. All the way up to here. That was my mistake. Sorry about that. Yeah, the solution set extends all the way up there, so it's not 9, it's 10. So the area will be base times height divided by 2. So obviously 50 divided by 2 gives us an area of 25. Now I really like thinking about the last question, letter D. Why does the dashed line of one of the borders, and that's this border, my x equals 4 border, why does that make no difference in terms of the area? All right, think about that for a second. This is actually a little bit of a tricky question. I just dropped my pen. But think about why the dashed line doesn't make a difference in terms of the area. All right, pause the video now. Okay, I'm going to retrieve my pen. Oh, and I'm back. Hey, hi. Okay, so here's the reason. Lines have no area. So in other words, the dashed nature of that line doesn't affect how much space is within the figure. Doesn't affect it whatsoever. All right. In fact, right, because the lines have no area, all 3 of the borders could have been dashed and the area that was shaded would have still been 25 units. Okay, so there's a lot on this page, lots of colors. I'm going to clear out the text pretty soon, so pause the video now. All right, here we go. Let's finish up the lesson. So today what we did is we solved systems of inequalities. And really what we did was we put together a lot of skills that we've been building up. We already knew how to evaluate the truth and the falsehood of an inequality at a given point. We also knew how to shade the solution set to a single inequality in 2 variables. And we also knew that a system of inequalities, or equations for that matter, consisted of all common points. In other words, here where the 2 shading, or in that last example, 3 shading areas overlap. Okay. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. Until next time, my name is Kirk Weiler. Keep thinking and keep solving problems.